In these couple examples, we're going to be finding the area under the curve of the definite integrals. And so we're going to kind of show, let's do some math and walk through the process here. So we're finding the area under this quadratic from 0 to 10. And so we are going to do the antiderivative, which is us adding a power and dividing by that power, minus, we'll add a power, divide by that power. And we're going to go from 0 to 10. And so this is going to be 30x squared minus 2x to the third. And we will be plugging in our bounds. So we'll plug in the bigger bound. And so that's going to be a 30 times 10 squared minus 2 times 10 cubed. So that's the area of the first minus, we're going to be plugging in 0. So if we plug in 0 into that, that's just going to make a 0. All right. And so the math is really figuring out what this all adds up to. So this is going to be 100 times 30. It's going to be 3,000. And then this is going to be 1,000 times negative 2, so minus 2,000. Get rid of the minus 0. So 3,000 minus 2,000 is going to be 1,000. So that area under that quadratic would be 1,000 from 0 to 10. And then if we do this problem, so it kind of notches it up a little bit more complicated. And if you notice, we're dealing with a square root. It's not really a coincidence that we have these perfect squares in here, because even when you do the antiderivative, you're still going to have something related to a square root. So for us, one of the nicer things is that if we were to do the derivative, we would kind of adjust this into a fractional exponent, a rational exponent. We're going to do the same because it's going to make it easier for us to go backwards. So two things that I'm going to do is I'm going to rewrite this as an x to the 1/2, but I'm also going to take the 3 out. And that is just going to simplify my math. I don't have to worry about the 3 at all. I could technically break these in individual pieces and pull these 60s and 6s out. But I know I'm going to get a fraction, and it just might be easier if I don't have to deal with the fraction until the end. And so this is me just rewriting it. And then I'm going to start to do the antiderivative to this. So this is just the rewrite. I'm not doing the math quite yet. So when I'm doing the math here, we're going to add a power. So we're going to add 1 to 1/2, and that's going to give you a 3/2. And we're going to divide by that 3/2. So we can kind of complicate this a little bit by dividing by a fraction, but we can also make it maybe a little easier by, instead of dividing by 3/2, we're going to multiply by the reciprocal. Right? I know that anytime I have a fractional exponent, I'm going to end up multiplying by the reciprocal rather than dividing by the fraction. And then I'm going to go from 4 to 16. So let's simplify this. We'll take 3 divided by the 3 times by the 2. We're looking at an 2x to the 3/2 from 4 to 6. So we'll plug in. So 2 to the 16 to the 3/2, minus 2 times 4 to the 3/2. All right, so I got to figure out what those values are going to become. And so if I have a 3/2 power, the denominator is a square root, and the numerator is, I'm going to cube that. So I'm going to square root the 16 and then cube it. And I'm going to square root the 4 and then cube it. That's kind of the math that I'm doing. So if I square root the 16, that's a 4, and 4 cubed is 64. So times 2. So 2 times 64 minus 2 times, I'm going to square root that. That square root the 4 is 2, and then cube it gets me an 8. So we're looking at 128 minus 16. And if I do that, I'm going to get 112. So my area under that curve is 112. And the area under this curve was 1,000. And in the next video, we'll focus on those two.